same general molecular formula. Members of a homologous series possess what? The same general molecular formula. Members of a homologous series possess the same general molecular formula. Members of a homologous series possess the same general molecular formula. Okay, now there are so many others but let's just concentrate on these ones. Read up the rest. The rest is there is a as the number of carbon atoms increases, there is a change from gas to liquid to solid, and so on and so forth. Read up those ones. Those are not important. I just had to mention this so that we understand what a homologous series is and what a functional group is. Now, we are going to be discussing the major homologous series with respect to our curriculum. Am I communicating? The major ones with respect to what we're going to be seeing. Remember, as I said, this is not a complete study on organic chemistry. It is a preparation class, implying that what we are concentrating on is likely things you have to see in JAMB exam. Am I communicating? Good. So, organic chemistry in a table. The first part of the table is the homologous series. Homologous weighting series. Second part of the table is the functional group. Is what? Functional group. Third part of the table is the general molecular formula. Fourth part of the table, hey, now my handwriting, Jesus. Even me, I know they even say what they write. Una de see am? Okay, una de see am. Online people, una de see am. They will respond. They said no, right? Okay. Una de hear me, Jare. It's not my fault. I do not like writing in primary school. Hey, wait a minute, this one why I even writing again. General molecular formula. Hope. Is it because of bad handwriting or bad service? Which one is there no for? General structural. General structural formula. So we're going to be taking this gingerly. Oh, Jesus. We're going to be taking it small. Wanyoli. Till we are done. But we'll try to hasten up a little bit. Now, the first guy I'm going to talk about is not necessarily a homologous series. It exists as a substituent, and that is alkyl. What did I call it? Alkyl is not a homologous series. It is a substituent. That is, it is attached to a parent chain. Am I communicating? Good. So, when you talk about your alkyl groups are basically formed when you remove one hydrogen from corresponding alkane. Oh yeah, side note. You know I told you have the table, but then you have a side note where you'll be jotting things down. So if you have your side notes, go to your side note and write. Alkyl group is formed when corresponding alkanes lose one hydrogen atom. Alkyl group. Alkyl. What did I say? Alkyl group is what? Formed. When weighting happen? Corresponding alkane loses one atom. So when a corresponding alkane loses one atom, what is formed? Alkyl. Now, it is simple to understand. We will do naming after this, but let's understand all of them. So that when we are naming them, you will know what you are naming. If I have an alkane, CH4. Are you listening to me? If you have what? An alkane, CH4. And I want to form an alkyl. How many hydrogen will I remove? CH3. Then bond. You know this bond will not be free. That's why it's occurring as a substituent, because it will be attached to something. Am I communicating? If I have an alkane, C2H6, what is... So it's not existing on its own. However, it occurs as a substituent, and you need to understand and know how it is named. Am I communicating? Good. So with that said, we go to the very next one. A functional group. You know, get functional group. General molecular formula, it has. The general molecular formula is CnH2n plus 1. Then it is represented by R most of the times. It is represented by what? R most of the time. So put this down quickly. So I'll go to the next important one. Alkane. Alkane. Now, as I said, when you talk about your hydrocarbons classified into aromatics and aliphatics, right? Aliphatics are classified into cyclic and acyclic. Acyclic are classified into alkanes, alkenes, and alkynes. So alkanes are hydrocarbons that possess only single bonds. Their functional group is the fact that they are hydrocarbons with only what? Single. You know, I said it earlier on, that functional groups could be heteroatoms, there could be bonds. So the type of bond a particular compound has can determine the properties. The presence of an extra or heteroatom can also determine the properties. In the case of alkanes, the functional group, just write it like this: hydrocarbon with only single bonds. Hydrocarbon with only waiting single bonds. Now listen, if you are talking about a hydrocarbon with only single bonds, you are referring to alkane. So what type of hybridization occurs in all the carbons in alkane? sp3, correct. Am I communicating? You know, the reason for multiple bond is presence of pi bond. Am I communicating? And if there is no pi bond, there will be no multiple bonds. Okay, I'm re-explaining. Okay, sorry, online people, if you like say una not been there here, sorry for that. Sorry, you know, say we get 2 classes. So listen, if you are online, alkyl is not a homologous series. However, we need to understand it. You get what I'm saying? It is just a substituent. And how is it formed? You form an alkyl by removing one hydrogen from a corresponding alkane. If you have an alkane, methane is CH4, and you want to get the corresponding alkyl, what do? Remove how many hydrogens? 1. It will now become CH3. If this is methane, what would this one be? Methyl. Am I communicating? I take it again. Alkyl is not necessarily a homologous series. It's basically a substituent, an attachment of carbon and hydrogen. But then, it's important we know it. That's why I'm including it here. How is it formed? Remove one hydrogen from corresponding alkane, and you get what? The alkyl. So, if you have methane, CH4, remove one hydrogen, what will you have? What is it now? C2H6, ethane. Remove one hydrogen, C2H5 dash. What do you have? Ethane. I hope this is understood. Okay, so that's that. That's why I now said that the general molecular formula is CnH2n plus 1. This general molecular formula is very important because it will help you determine the molecular formula even if you don't know the substance. For instance, give me the general molecular formula of an alkyl that has 1,000 carbon atoms. What will it become? Alkyl, right? So it will be C, N is 1,000. H, 2 times 1,000, because N is 1,000. Then plus what? 1. All right, let's do this. C 1000. H 2 times 1000. 2000. Plus 1 is 2001. Is it hard? You have never heard of it before. Even me, I cannot name that compound. Don't you dare. Uncle, what is the name? Yahid. Okay, 1010, okay. I cannot name it. Now let's continue. So, I was saying something. So that's that. The importance of a general molecular formula is that you can use it to form the molecular formula of any member of that homologous series. Am I communicating with you? Good. So for alkyl is CnH2n plus 1. For alkane, I now say that the alkane, they are hydrocarbons with only single bonds. Once you are looking at a hydrocarbon and the bonds in the hydrocarbon are single bonds, what are they referred to as? Alkanes. Remember, the form of hybridization for single bond alone is what? sp3. Because for you to have multiple bond, there must be pi bond. If you have 1 pi bond, it will be double bond. 2 pi bonds, triple bond. No pi bond. No pi bond, single bonds. Am I communicating? Okay. So what do you have here? Cn H2n plus 2. You know this one now. Very good. That means if we are looking at the structural formula, it is going to be an alkyl group attached to hydrogen. Alkyl group attached to hydrogen. Now let's come back. N starts from 1. That is to say, there is no alkane that is lesser than 1 carbon. There is no alkane that has less than what? 1 carbon. So it starts from 1 to 2 to 3 till infinity. Okay, put that down. Now, that means that if, for instance, I ask you a question, listen, see this question. Yes, remember, it is an exam preparation class, so I could just step in and down. And you are asked, what is the number of hydrogen atoms? Right? Right? Side note, side note, side note. Side. You know, I said, write a table, then have a side note. What is the number of hydrogen atoms? What is what? The number of what? Hydrogen atoms contained in an alkane. Sure, you heard the homologous series. Did you all hear the homologous series? Contained in what? An alkane. When you hear alkane, what is the general molecular formula that should come to your head? Cn H2n plus 2. Thank you. So I said, what is the number of hydrogen atoms, right? Contained in an alkane which has 16 carbon atoms. Which has what? 16 carbon atoms. 16 carbon atoms. Is that solvable? Very simple. What do you do? The number of carbon atoms is n. So if it has 16, Cn H2n plus 2. We are looking for hydrogen, right? So let's get to work. C, what is C? H, 2 times 16 plus 2. What do you have? C16, H, 2 times 16, 32 plus 2, 34. Is it hard? Okay. So are we seeing the kind of question? Remember, JAMB is not going to ask you, what is alkane? They might not even ask you, okay, yes, I've seen questions where they ask you the general molecular formula. But you are not going to be asked straightforward questions. You are expected to know how to apply your knowledge. They don't necessarily care about what you know. They are concentrated on how you can apply what you do, what you know. If I said, for instance, that a particular alkane has 12 hydrogen atoms, what is the number of carbon atoms in the alkane? 12 hydrogen atoms. 12 hydrogen atoms. Let's solve it. Let's solve it. Let's solve it. Listen. A particular alkane has what? 12 hydrogen atoms. What is the number of carbon? Now watch it. It means that here will be Cn, or let's call it X. And then here is H what? 12. Is it not? So to find X, we need to find N. Are we getting what I'm saying? So let's equate it. N is equals X, right? And 12 is equals what? 2n plus what? 2. It's not a simultaneous equation. I'm just trying to emphasize something. So let's get to work. What do we do? Collect like terms, right? So 2 will go over. What will it become? 12 minus 2 will be equals to n. What are you going to have? 12 minus 2 is what? 10 equals what? 2n. Divide by 2. Divide by 2. What do you have? 5. N is equals what? 5. Do we see how to solve these kind of questions? Okay. So imagine I ask another one. An alkane has 30. Hey, I'm coming soon. Sorry about that. Let's say an alkane has about 26 carbon atoms. What is the number of 26 carbon atoms? What is the number of hydrogen in how many? How many? 26 carbon atoms. What is the number of hydrogen atoms? 50. Waiting. 26 carbon. Carbon. 26 carbon. How many hydrogen? C 26 bar H2 bracket 26 plus 2. What is this? Plus 2. What do you have? 54. Am I communicating? Good. Moving ahead. Moving ahead. Okay. Now with that said, how do you get the general structural formula? Attach an alkyl to hydrogen and you have an alkane. So when I have CH3 attached to hydrogen, what does it become? CH4. Attach an alkyl to hydrogen and you have the corresponding alkane. Attach an alkyl to hydrogen and you have what? Corresponding alkane. Now, side note. There are okay. So I take it again. When you attach an alkyl to hydrogen, what did I say you will get? A corresponding alkane. Attach an alkyl to hydrogen and you get a corresponding alkane. So when I attach C2H5 to hydrogen, what am I going to get? Are you getting what I'm saying? Good. Moving ahead now. Side note. One characteristic feature of an alkane is that when it is burning, whenever an alkane is burning, it combusts with pale blue, non-luminous flames. What did I say? Pale blue, non-luminous flames. Pale blue, pale. Pale waiting, blue. Whenever an alkane is burning or combusting. When alkanes burn, they burn with what? Pale blue, non-luminous flames. Okay, now, what do I mean by that? A very good example of your alkane is your cooking gas. Your cooking gas is a mixture of your propane and butane. What did I say? Cooking gas is a mixture of waiting, propane and butane. In fact, let me just say this. Just have this in mind. Listen. That anytime you are looking at a substance associated with fueling. With what? Fueling combustion reaction. When you say fuel, you know, say for Nigeria, when you say fuel, now the one where they put for car, kerosene. Now the one where they put for then gas. And the one where they put for a gas cylinder. It's just like when we say Indomie. Tommy, Indomie. You know they exist. There's nothing like no Maggi. You get. Yes, now. It's seasoning cube. Maggi Star is a company on your own. No, it's a company on. There is no Royco Maggi. There is no Mini-Me Indomie. I can't forget that experience. I went to buy Mini-Me. And I stepped in and I was like, Madam, do you have Mini-Me noodles? Mini-Me noodles. She said, no. Now what she has is Mini-Me Chim Chim. I was like, no, Mini-Me Indomie. She was like, okay, do you mean Mini-Me Indomie? And she was seeing me as the person that does not know anything. You get it? It's not your fault. Environment. It's all right. But I'm not sure there's any place in Nigeria where they use noodle. Even all these touche place. Where? Now I don't be everybody they call her. It's all right. Let's continue. Now, anytime, listen. If you are looking at a fueling agent is anything that supports combustion. Anything that supports waiting, combustion is referred to as what? Fuel. The one you are putting in your car is not fuel. It's gasoline. Petrol. Is what? Gasoline. What did I call it? Petrol. Whether it's gasoline or petrol, that's the one you put inside your car. Kerosene is a fuel. Are you getting what I'm saying? All of diesel, they are all fuels. Fuels are that they are things that support what? Combustion. And the homologous series that is mostly associated with fueling is alkanes. So if you have a question and they ask you, which one of these is used as a fuel, and you see ethanol, you see methane, you see methanoic acid, and you see formalin, what is the answer? Anytime you think of an alkane, think of it as a fueling agent. Am I communicating? Okay. Sorry, you know, say our online classes, they are as important as you people. You get, so let's bear with them. So as I was saying, they are not complaining. It's just that some people are not using smartphones. Their phone is not smart. So their phone have caught half of the board. They are not seeing that side. You understand? Okay, so as I was saying, you know, I told people that iPhone and iTel. I told you that the complete name is iTelephone. The other one is still iTelephone. What is the difference? In iPhone, they cannot tell. Are you guys what I'm saying? Then in iTel, they cannot phone. You see why iTel a rubbish phone? They removed the main thing, the phone. So you might be using iTel. That's why you're only seeing half. Everything I'm saying is half. You are saying I should stop now. Makanine use the iTel. It's all right. I use an iTel phone, and I'm proud of it because it's still an iPhone. Yes. iTelephone is the general name. If you won't believe it, you can sue me if you want to. As I was saying. Now, anytime you think about, generally, when you talk about fueling agents, that's why cooking, we use kerosene, in our stove. And I told you that your cooking gas, is what and what now? Propanone. Propane and butane. When you mix them together, you get your cooking gas. Are you getting what I'm saying? And now let's come back. Now, if you look at your cooking gas, when you lighten your cooking gas and the flames are coming out, do you notice that one is pale blue? Secondly is, if you put off the lights in the kitchen in the night, can you use that pale blue light to see anything? So you see why it is pale blue non-luminous. Am I communicating with you now? Good, so have that in mind. Now, secondly is alkanes. When you talk about their chemical reactions, they undergo two major chemical reactions: combustion and substitution. Now, their reactions are limited because of the absence of a pi bond. What limits the reactions of alkane is absence of what? Put it down. Reactions in alkanes are limited due to the absence of pi bond. So, if you compare the reactivity of an alkane to the reactivity of an alkene to the reactivity of an alkyne, you find out that the alkane is the least reactive. Are you getting what I'm saying? Because it does not have pi bond at all. Okay, imagine I ask you, listen, Ewo, what are you writing? Sorry. Okay, I should say it properly. Okay. Reactions in alkanes are limited due to the absence of pi bonds. This implies that alkanes are the least reactive hydrocarbons. Reactions in alkanes, pi. I have said this before now, pi r squared, pi. Sure, you know people where they mind pi. Shall we say we should mind December, don't worry, it will pay. Now so Bitcoin said to you go still pay, don't worry. We go the mine now. See, as I used to the advertise pi. So as I was saying, pi bond, ba? Shape pi bond, ba? Good. Now, I told you that the pi bond, please listen. Listen. The pi bond is actually made up of it's let's say it contains electrons. And those electrons are actually free for sharing. Are you getting what I'm saying? They are not combined strongly. Are you getting what I'm saying? Hence, if you have extra atoms or molecules or compounds come in contact with them, they can easily split and react. But if you have a sigma bond, the bond is strong. Sigma bond is what? Is strong. Sigma bonds are stronger than pi bonds. So it's easier to break a pi bond than to break a what? A sigma bond. Now, if you only have sigma bonds, like in alkanes, what types of bonds do you have? Only sigma bonds. It implies that there is no pi bond, so reactivity is reduced. But in alkenes, you have what? One pi bond. One pi bond. In alkynes, how many pi bonds do you have? Two. So if you happen to see a question, I see a question. Number 29. Those that will write at Yamufu. The most reactive hydrocarbon is dash. Option A, alkane. Option B, alkene. Option C, alkyne. Why? It has the most pi bond. So the more your pi bond, the more your reactivity. Sorry, am I communicating with you? Good. All right, let's continue. Now, because of that, alkane reaction, I said they are limited to what and what? Substitution and what? Combustion. When you say combustion, please listen. Listen, no, listen. You know, say, I talk, say, we go the right main table, the right waiting, side note. When you talk about combustion occurs in three possible ways. There is, listen, complete combustion. Complete combustion is when there is excess oxygen. What did I say is complete combustion? When there is what? Excess oxygen. If oxygen is everywhere, is in excess, you refer to it as what? Complete combustion. There are only two products of complete combustion of hydrocarbons, whether alkanes, alkenes, alkynes. So put that down. There are only two products of complete combustions of hydrocarbons. There are only two products of complete combustion of hydrocarbons. There are only two products of complete combustions of hydrocarbon. There are only how many products? Two products of complete combustion of what? Hydrocarbons. Number one, carbon 4 oxide. Number one is what? Carbon 4 oxide. Number two is water. 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 Mmiri. Number two is mmiri. Number two is what? Water. Water. I said complete combustion of any hydrocarbon, whether it is an alkane, an alkyne, alkane, alkyne, alkane, whether you are dealing with anyone. Once it's a hydrocarbon, complete combustion, what did I say it will give? Carbon 4 oxide and water. Complete. I hope I'm communicating with you. Good. Now, there's a general formula for complete combustion of these guys, and that general formula works for anybody. If you have a problem with balancing, you can use this for balancing complete combustion reactions. When we'll be doing inorganic stoichiometry, I want to clean this. When we'll be doing inorganic stoichiometry, you will find out that, listen, that before you do any reaction or happen to solve any stoichiometric question, you must have a balanced equation. You must have what? Okay, so let's look at this guy. CX HY plus bracket X plus. You know it. You are too much. I tell people. Well, let me shift for them. Let me shift for them. Okay. We go again. HY. Plus. X plus 4. I did not make mistake. Sure, you know. I was checking if people are following. That's why. Plus Y over 2. Okay. If you use this guy, you can balance Any. What did I say? Any combustion reaction, complete combustion reaction of any hydrocarbon with that formula. So put it down. CXHY plus X plus Y over 4 brackets O2 reacting to give XCO2 plus YH2O. Okay. Don't worry. I was not falling. I wanted to sit down. I was not. I wanted to sit down. Don't think of it that way. Okay. Now we'll try out some questions with respect to this. Right. I should wait. This is organic related, inorganic question. So right. How many moles of oxygen is required for complete combustion of pentane? How many moles of oxygen is required for complete combustion of what now? Pentane. Pentane. Now, please hold on. Let me say something. Listen. When you say pentane, pent means how many? 5. We'll still do naming immediately after this. And when we are studying naming, you'll find out that when you're naming organic compounds, generally speaking, there are 3 parts of the name: the infix, the suffix, and the prefix. We'll talk about that. But before that now, when you say pentane, ANE is the suffix which describes alkanes. It identifies what? Alkanes. That's what suffix. The major part of a particular name is the suffix, and suffix identify or indicate the homologous series. So if you see ANE, what homologous series should come to your mind? Alkane. If you see OL, alkanol. Am I communicating? If you see AL, alkanal. Am I communicating? And let's let that slide and come back. So we have this particular guy. We are dealing with pentane. What is the general molecular formula of an alkane? CN waiting plus 2. So when we say pentane, what will it become? C5 H2 times 5 plus 2. What would that be? H10 plus 2, which is 12. So we have him. Let's put him here. Now we apply. We do what? Apply. C5 H12 plus, what do you have? X is 5 bar. 5 plus Y is what? 12. All over 4. Ewo. 5. O2. Reacting to give, what is this? 5 CO2 plus 12 over 2 H2O. Now let's reduce them to the lowest possible terms. Now please, I hope you know that this is not 5 plus 12 all over 4. It is 5 plus 12 over 4. Separate. C5 H12 plus, what do you have? 5 plus 3, right? O2 reacting to give 5 CO2 plus 6 waiting H2O. Oh yeah. What do we have? So in place of this we have 8. Is it balanced? Obviously. So how many moles of oxygen are required for complete combustion of pentane? 8 moles. Is it hard? Oh yeah, try this one. Oh, you want to write this one first? If you write, it's your business. But what if you don't write? It is whose business? Still your business. I don't care. I mean, they write the exam. Shey na you hit go they do inside her. Oh God. Who na go hear am? I don't think it's like that anymore. But I remember my first jam exam was crazy. In fact, in the hall, people were pulling their shirt to wait. With the rights like this, I don't know whether now the heat from the system, a bit from our brain. We are sweating. This will put on fan. On top of the fan, we are sweating. They put on AC. On top of the AC, we are still sweating. Although they think it's by opening window. They went to open window. If you put AC, they used to open window. But this village people, they look at it, they're like, God, this is too much. They went to open window. People were sweating. You come on shirt. So, no joke. But you will not come on shirt in Jesus' name. You will write it sweatlessly. Sweat. You understand? Because all you are going to see is what is already given. Understood? The one you don't know. What did I say? It will not come out. If you believe it, you can receive it. Did I say you will receive it? I said you can. Okay. I hope you're communicating. Okay, let's move on. Oh yeah, what is the number of moles of oxygen required to? What is the number of moles of oxygen required to completely combust an alkane? The number of moles of oxygen required to completely combust an alkane with 2 carbon atoms. An alkane with 2 carbon atoms. What do you have? An alkane with 2 carbon atoms. The number of oxygen required to completely combust an alkane with 2 carbon atoms. What do you have? 3 points. 3 points. Okay. So let's look it up. Let's look it up. How did we get it? 2 carbon atoms. We are going to use the general molecular formula to find it. So if it is alkane, it's CnH2n plus 2. What is N? 2 carbon. So C2, H2 times 2, 4. 4 plus 2, 6. So what is our X? What is our X? What is our Y? Oh yeah, let's apply it. C6. It's not mistake, it's just. I just want to check if you are following. Normal, ba? You know I cannot make the mistake. So let's continue. Plus, what is X? Now, what's X? What is Y? O2, 2CO2 plus weighting, 6/2 H2O. Oh yeah, let's get to work. C2H6 plus LCM 4. What do you have? I did not make mistake. It's just 8 bar plus 6. O2 bar reacting to give what? 2CO2 plus 3 H2O. Please, are you following the mathematics? Okay, 8 plus 6 is what? So what do you have? C2H6 plus 14/4, which is reduced to what? 14/4 is what? 7/weighting 2 O2 reacting to give 2CO2 plus 3 H2O. Now, if you are dealing with complete combustion of 1 mole, please, what will it become? 7/2. Am I communicating? Complete combustion of 1 mole. What will it become? 7/2, which is the same thing as 3.5. Am I communicating? Now, but most times we don't like leaving our equations like this in fractions. So how do you make it a non-fraction equation? Multiply by the denominator. And then what do you have? Times 2. 2 cancels, right? Times 2 here becomes 4. Times 2 here becomes 6. And that's that. So let's continue. Now, with that said, let's go to the next one. Substitution reaction normally is replacement, right? Bench, we call it substitutes, right? For match. You get what I talk? For match now, football match. You don't know football match? You don't know football match? If they want substitute person, how does it happen? One person goes in, one person goes out. Am I communicating? When you're substituting for, you get what I'm saying? One person has to go in, the other person has to do what? Go out. I hope I'm communicating. Good. Now let's continue. As I said, recapping, listen. when you are dealing with substitution, it is a replacement reaction. What did I say? It is what? So you are replacing something with what is already there. Am I communicating? So imagine you, and what is being replaced during substitution is hydrogen. What did I say is replaced? What is being replaced? Hydrogen. So if you replace hydrogen with chlorine, the reaction is substituting chlorine. Am I communicating with you? Good. So let's move ahead. I don't want us to dwell on this part. Now let's go on. The next one I'm going to talk about is alkene. What did I say? Alkene. Alke what? Kene. Alkene. You call them the olefins. That is trivially the olefins. So the third guy is alkenes. Alkenes, functional group is double bond. So carbon, carbon, double bond. Carbon to carbon, not just any double bond. Please, am I communicating? Carbon to carbon waiting, double bond. Please put that down. Carbon to carbon, double bond. Because if you have a carbon to oxygen double bond, yes, it's possible, the carbonyl. But that's not an alkene. So carbon to carbon double bond is what? The functional group of alkenes. Carbon to carbon. So it means that the double bond has to exist between at least two carbon atoms. Am I communicating? Now, the general molecular formula of alkenes, CnH2n, where N starts from 2. Why does it start from 2, right? It's common sense now. The pipe double bond must exist between at least how many carbon atoms? 2. So, because you need at least 2 carbon atoms, the least number of alkenes is from what? From 2. So, the least possible alkene is ethene. Is what? We'll discuss naming. Just be grabbing this thing small. N starts from where? 2 in alkenes. So, if I am to say ethene is the least possible guy, what would the molecular formula be? C2H2 times what? 2. What do you have? C2H4. Is it hard? Oh yeah, let's go ahead. So when you talk about the general structural formula, you have R attached to C, hydrogen, double bond C, R, hydrogen. Put it down like this. My point is, the structure must have a double bond between carbon atoms. That's what it's trying to say. Now, did you notice something? Hybridization here is sp2. S and P2, meaning that there are 3 sigma bonds. How many atoms is it directly attached to? 1, 2, 3. I hope I'm communicating with you. Good. Okay, move ahead. Now, with that said, when you come to your alkenes, we'll still talk about lab preparation, so don't bother. The reactions that can occur in alkenes, but did you notice that corresponding alkenes and corresponding alkanes differ by how many hydrogen atoms? 2. Did you notice that? Because if you have ethane, it will be C2. Let me use a better marker. Ethane, C2, H2 times 2, 4 plus 2 by H6. But ethene, C2 waiting, H4. Now, did you see the difference now? What is the difference between a corresponding alkane and alkene? 2 hydrogen. 2 what? Are you getting what I'm saying? Then we used to have plus 2. Now, what do we have? Nothing. Am I communicating? Good. So just have that in mind. These are some technical questions that you could be asked. And then you are wondering, what do they mean by the difference between corresponding alkene and alkane? Are we getting? It's just that the hydrogen in alkene, if we check the same alkane or corresponding alkane, it is different by how many? By 2. Okay, moving ahead. Alkenes are more reactive because of the presence of the pi bond. I mentioned that, right? Good. And they undergo 3 major reactions. How many major reactions? Number one is combustion reaction. Number one is what? Combustion reaction. Number two is addition reaction. Number two is what? Addition reaction. And number three is polymerization. Combustion reaction, addition reaction, and polymerization. These are the three major reactions that your alkenes undergo. So listen. If you talk about combustion, it is burning in oxygen. Are you getting? We know the product now for complete. What is it? Carbon 4 oxide and water. That aside. Now, let's come down to addition. Addition reactions only give one product. What did I say? Addition reaction only gives how many products? One product. So if you are dealing with an addition reaction, you will only have one product on the product side, or one substance on the product side. For instance, if you are doing hydrogenation is addition of hydrogen. Let's say you are hydrogenating. See what happens. Please listen. See what happens. Please listen. If you are adding hydrogen, oh my God, I tell. Let me move to this side. We've written these things now, right? Okay. Let's say you are trying to add hydrogen. Are we listening? Plus hydrogen. Now, see what usually happens here. Because of the fact that you have a pi bond, which is a weak bond, the atoms of the guy you are combining, or the atom or anything, molecule you are combining, will start attacking the pi bonds. One hydrogen will attack one side, the other hydrogen will attack the other side. So I can rewrite this and I will have H bonded to H. Please, is this still H2? So one of these hydrogen will start attacking this carbon here to break this bond, while this other one will start attacking it to break this bond. Are you following me? If that attack happens and it breaks it, it will collect the bond. So this one will now collect it. This other one will now collect it. So you notice that when you hydrogenate, what is going to be your product? See? Hydrogen, hydrogen, right? See? Hydrogen, hydrogen. Then because this bond is broken, hydrogen takes one, right? Then the other side, hydrogen takes one. How many products do you have? One. So in addition reaction, you only have how many products? One. I hope this is clear. Now, I want to talk about Markovnikov's rule. What did I say? You know, in this particular addition reaction, it has to do with, listen, please listen. It has to do with a homoatomic molecule. What did I call it? Homoatomic. What I'm trying to say is that the atoms there in this molecule are both the same thing. Hydrogen, hydrogen. Now, if for instance, you have different elements inside one molecule and it is undergoing addition reaction, it must follow a rule known as what? Markovnikov's rule. Markovnikov's rule is saying that whenever addition of a heteroatom containing hydrogen occurs, hydrogen attacks the carbon with more hydrogen. It attacks the carbon of the double bond with more hydrogen, while the heteroatom will attack the other carbon with less hydrogen. So you check here, how many hydrogen do you have? Here, how many do you have? One. So when the attack is going on, this guy will go here, this guy will go here, here. So is it 2 bromo or 1 bromo? 2 bromo. Am I communicating now? Is this confusing? It is, but you know, you understood it now, right? Good. Okay. You now write it. Oh yeah, Markovnikov's rule. Markovnikov's rule states that during the addition reaction, during the addition reaction of a heteroatom containing hydrogen, during the addition reaction of what? A heteroatom containing what? Hydrogen, comma. during the addition reaction of a heteroatom containing hydrogen, comma. Are we there? Hydrogen atom, the hydrogen atom of the heteroatomic molecule, the hydrogen atom of the heteroatomic molecule attacks the carbon double bond with more hydrogen. Hydrogen atom of the heteroatomic molecule attacks hydrogen atom of the heteroatomic molecule. Which one will it attack? It attacks the carbon double bond with more hydrogen. It attacks the carbon double bond with more hydrogen. While the heteroatom attacks the carbon double bond with less hydrogen. I take it again. Markovnikov's rule states that during the addition reaction of a heteroatomic molecule containing hydrogen, comma, the hydrogen atom of the heteroatomic molecule attacks the carbon double bond with what? More hydrogen. While the heteroatom attacks the carbon double bond with what? Less hydrogen. Please, I hope I'm communicating. Good. Full stop. Full waiting. Stop. We move ahead. Yes. This one that now has 3H. Please, are we adding to the double bond or to the single bond? To the carbon-carbon single bond or the carbon-carbon double bond? It's double bond now, so this guy has nothing to do with what we are discussing. Am I communicating? You are trying to break a pi bond. I told you addition reaction is as a result of breaking of what bond now? Pi bond. Am I communicating? Good. So let's continue. Okay, leaving this guy. Yes, ma'am. Please, what is octane number? Okay, briefly. That's petroleum, but then just have the definition. Octane number is basically the ratio of isooctane to N-heptane in petrol. The ratio of isooctane to N-heptane in petrol. Isooctane to what? N-waiting. N-heptane. N-heptane. Isooctane to N-heptane. They can't see it online. Okay. Right? Darkness. I'll be video half off. Yeah. Online people, we are coming. Want to put our generator. Okay, so for now, just be listening. I said, octane number is the ratio of weighting to weighting. Isooctane to N-heptane. Am I communicating? In a given amount of petrol. In a given amount of what? Of petrol. So it is what is used to determine the quality of fuel. Of petrol, I meant to say. It is used to determine the quality of what? Of petrol. Now listen, if the ratio of isooctane is higher than the ratio of N-heptane, there is no addition. It is only replacement, substitution. Am I communicating? Good. Moving ahead, please, for want of time. Test for unsaturation. Test for unsaturation. The reagents used to test for unsaturation is bromine water. Is what? Bromine water. The reagent used to test for unsaturation is what? Bromine water. The reagent used to test for unsaturation is what? Bromine water. The reagent used to test for unsaturation is what? Bromine water. Oh yeah, let's continue. Let's jump into alkynes for want of time. Now, you write alkynes. The functional group of alkynes is triple bond between carbon atoms. What did I say? Triple bonds triple bonds between what? Between carbon atoms. The implication of that statement is that once you are talking about an alkyne, there must be at least one triple bond between two carbon atoms. Am I communicating with you? There must be at least how many triple bond? One triple bond between carbon atoms. And with that said, the general molecular formula is CnH2n minus 2. What did I say? What is the general molecular formula of alkynes? Alkynes, oh sorry. Why? Alkynes. CnH2n minus 2. What is the formula of an alkyne which has 7 carbon atoms? What is your answer? C7H12, right? What did you do? Cn is C7, H2 times 7 is what? Minus 2 is what? Of your Let's continue. Now, what is the general structural formula? Same thing. R attached to C, triple bond C, R. Linear structure. You are noticing it. Around the triple bond, linear structure. What form of hybridization will you find here? SP. Now, but it doesn't mean that other carbon atoms. You know, if the other carbon atom is single bond, what is there? SP3. Am I communicating? But in when triple bond now, this is SP and this is SP. If, for instance, you had CH3, C and CH. This one, what hybridization? This one, what hybridization? But this one that has only single bond between is SP3. Am I communicating with you? Good. So let's continue. Now, there is one special thing about alkynes that differentiates them somehow from alkenes. And that is, listen, the normal reaction in alkynes are the same with alkenes because they are both unsaturated. It's just that when you do an addition reaction, if you use 1 mole of a substance added to an alkene, you will use 2 moles to completely saturate an alkyne. If you are to saturate an alkene with 1 mole, how many moles will you use to saturate 2? Am I communicating with you? So you use double of whatever you use to saturate the alkene to saturate what? The alkyne. The difference in the hydrogen atoms between alkyne and alkene is still how many? 2. But between alkyne and alkane is now what? 4. Am I communicating with you? For instance, ethane is C2H6. Ethene. Ethene. H4. Then ethyne. So are you noticing difference here? 2. Difference here? 2. Difference here? 4. Am I communicating? So just have that in mind. Now, alkynes and alkenes, their reaction still combustion, addition, and polymerization. However, there is a special reaction that is characteristic to terminal alkynes. Characteristic to what? I put that down. Terminal alkynes. Side note. Go to your side note. Terminal alkynes are characterized by the ability to undergo substitution reaction. Terminal alkynes are characterized by the ability to undergo what? Substitution reaction. Terminal alkynes are what? Characterized by the ability to undergo what type of reaction? Substitution reaction. Now, when you say terminal alkyne, I hope you know that it means that the triple bond occurs at the terminal. That's the end. So put that down. Terminal alkynes have the triple bond at the last carbon atom. Terminal alkynes have the triple bond at the waiting last end terminal carbon atom. Terminal alkynes have the triple bond at the terminal carbon atoms. So when the triple bond is existing at the end, please, what do you refer to it as? Terminal alkyne. Am I communicating? Full stop. Now, we move into the next aspect of this particular study, and that is that they have the ability to undergo substitution. That's the extra thing about alkynes. Alkene, addition, combustion, polymerization. Alkyne, addition, combustion, polymerization. But then terminal alkynes can undergo what? Substitution. Now, the substitution reaction usually occurs between sodium metal, right? The substitution reaction of alkynes usually occurs between sodium metals. Number 2, ammoniacal solution. How am I too fast? Oh yeah, let me slow down. Where should I start from? Of alkynes. That's where you stopped. Usually occurs substitution reactions in alkynes, in terminal alkynes, sorry. Share is terminal alkynes. Okay. Usually occurs with sodium metal. Sodium metal. Unanego sodium metal. II. Ammoniacal solutions of CuCl. That is copper 1 chloride. Copper 1 chloride. Ammoniacal solution of what? Copper 1 chloride, or ammoniacal solution, or ammoniacal solutions of silver trioxonitrate 5, AgNO3. So just in case you are asked, which one of these homologous series or which one of these unsaturated hydrocarbons, listen, which one of these unsaturated hydrocarbons undergoes substitution reaction? Option A. Option A. Option B. Are we following? Option C. Option D. None of the above. What is the answer? Why is it C? The only alkynes that undergo substitution reactions are terminal alkynes. So I take it again. Listen. I said that whenever you are dealing with terminal alkynes, they have a special reaction that other alkynes do not participate in. And that reaction is reaction with substitution reaction with sodium metal, ammoniacal solution of CuCl. This is copper 1 chloride, or ammoniacal solution of silver trioxonitrate 5. These are the 3 compounds or 3 substances that undergo substitution reaction with what type of alkynes now? Terminal alkynes. Meaning that if it is not a terminal alkyne, will this reaction occur? No. So I now ask the question. The question is, amongst these 3, which one of them, amongst these 3, which one of them would undergo substitution reaction with sodium? What's the answer? Why is it C? This is a terminal double bond, right? But is it an alkyne? Can it undergo substitution? What is this? Alkyne. Terminal or non-terminal? What is this? Terminal or non-terminal? Oh, sorry. Okay, so I hope that is clear. Good. We go to the next one quickly for want of time. Quickly. Monohaloalkanes. 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 Mono. Homologous series. Homologous series. Table. Back to the table. Okay, so for those online, listen. For those online, listen. For want of time, we just have. How many hours did you spend so far? What's the time? 4 o'clock. Jesus. Are you serious? Hey. Please, hold on. Please, for now, I will re-explain those things I talked about. Are you listening? I would re-explain them, but I wouldn't do it now. So please, for want of time, let's just run down these things. Just try to follow me from here. I'll talk about it and then possibly resend the video to the group. You will see it fully explained. In fact, I can decide to host a special explanation of that part after now. For want of time, please. Thank you very much. Now, let's continue. We'll go to the next homologous series. If you notice, I am just trying to touch major things that you can see as exam questions. I'm not telling you everything. Meaning that after this, you will still need to go back and do a little reading. Am I communicating? Okay. So, homologous series. Monohaloalkanes they are not much of a big deal. So just write, we'll just briefly breeze through them. Monohaloalkanes. Functional group is X, halogens. What did I say is the functional group? Halogens. What is the functional group of monohaloalkanes? Halogens. Halogens. What did I say? Halogens. If you are dealing with the general molecular formula of halogens, Cn H2n plus 1x. Cn H2n plus 1x. The implication of the statement is that hydrogen will be replaced. Sorry, a halogen will replace the hydrogen. And once a halogen replaces the hydrogen, you have a monohaloalkane. Am I communicating? X indicates what? Halogen. X indicates what? Halogen. So if you replace one hydrogen with X, what do you get? A monohaloalkane. Haloalkanes are actually very useful. Are you listening? They are actually very useful in industrial processes. For instance, your tetrachloromethane. Your tetra what? Okay, side note. Oh yeah, side note. Just briefly. Tetrachloromethane. Tetra. What did I say? Tetrachloromethane is majorly used as an organic solvent. Tetrachloromethane is majorly used as what? An organic solvent. Tetrachloromethane is majorly used as what? An organic solvent. So, if you happen to see a question, which one of these industries is tetrachloromethane majorly used? And you see laundry industry, cooking industry. Which one will you choose now? Laundry, because it would dissolve organic stains. Am I communicating with you? Good. Now, trichloromethane or chloroform. Trichloromethane or chloroform. Trichloromethane or what? Chloroform. Trichloromethane or what? Chloroform. Trichloromethane or chloroform. Are we there? Chloroform. Make I spell. Trichloromethane or what? Chloroform is majorly used as an anesthetic. So your anesthetic. Majorly used as what? All this is where they chook. Hey, Jesus. Injection, sure you know, before surgical procedures. So you are being injected with something that relieves you of the pain as they are sewing or cutting or doing any surgical procedure on your body. Now, however, trichloromethane is no longer in use. Am I communicating? Because it has extra side effects. So you know, chemistry advances, science is progressive. But it used to be used as what? An anesthetic. It relieves you of pain during surgical procedures. Then another important haloalkane is triiodomethane. 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 That one is antiseptics. Triiodomethane. Another name for triiodomethane is iodoform. Iodoform. Triiodomethane. Iodoform. Okay. Now, the iodoform reaction. Please listen. Listen. I should spell iodoform. Iodo. Okay. So I said triiodomethane. What is it used for? Iodoform. You're right. It is used in making antiseptics. Anti-wetting septics. Sure, you know that characteristic smell of them detol them eyes out them. Nah, iodoform. Now waiting. So the characteristic smell that all these cleaning agents is iodoform. Am I communicating with you? Good. So as I was saying, iodoform is majorly used in the making of your antiseptics, and it is responsible for that characteristic smell. Am I communicating with you? Good. So with that said, we go to the next one, and that one is What did I want to say? Yes, bromoethane. Bromoethane. Bromo. Yes, bromoethane. Bromo. BROMOETHANE. Bromo what? Ethane. Now, the bromoethane is majorly used in the making of tetraethyl lead 4. Bromoethane is majorly used in the making of what? Tetraethyl lead 4. Bromoethane is majorly used in the making of what? Tetraethyl lead 4. Bromoethane is majorly used in the making of what? Tetraethyl lead 4. Bromoethane is majorly used in the making of what? Tetraethyl lead 4. What is this used as? It is an additive agent. What did I call it? It is what? An additive reagent that prevents knocking. Am I communicating? When we do petroleum, please listen, we'll discuss this fully. But tetraethyl lead 4. Tetraethyl lead 4 is majorly used as what? A knocking, anti-knocking agent. Anti-knocking agent. Tetraethyl lead 4. What did I say it is used for? As an anti-knocking agent. What is used in the production of tetraethyl lead 4? Bromoethane. Okay, now let's continue. Now, when you talk about iodoform, there is a reaction known as the iodoform reaction. Please listen. Iodoform reaction involves the reaction of iodine in an alkaline solution. Iodoform reaction involves reaction of what? Iodine in what? An alkaline solution. Please try to follow me. Remember, I told you, I am not concentrating on in-depth details of each of the homologous series. I am simply concentrating on likely questions you will see. So listen. Iodoform reaction involves reaction with what? Iodine in what? An alkaline solution. Specifically sodium hydroxide. Specifically what? Sodium hydroxide. Now, the iodoform reaction is used to test for what we call the acetyl group. What we call what? Iodoform reaction is used to indicate the presence, right? Iodoform reaction is used to indicate the presence of iodoform reaction is used to indicate the presence of acetyl group. When you're looking at the acetyl, this is what you're looking at. CH3, C double bond O. Yes. Iodine in alkaline solutions. Alkaline solutions. Alkaline solutions. I said iodoform reaction is a reaction with iodine in an what? Alkaline solution. Now, bracket NaOH. Bracket what? NaOH. Are we listening? Good. Now, I said use it to test or indicate for what? The acetyl group. Now, when you are looking for your acetyl, acetyl is CH3 C double bond O. What did I say is acetyl? CH3 C double bond O. So any compound that has this acetyl group can actually undergo your iodoform reaction. For instance, your ethanol can undergo this reaction. Am I communicating with you? Your ethanol, we'll get to discuss that. But then just note this. When you hear iodoform, what group should come to your head? Acetyl, which is this guy. Am I communicating? As I said, this is a preparation for your exams. I'm calling questions that may or may not come out. But it will come out in just... Okay, let's leave that. Let's leave that. Let's leave that and come back. Okay. General structural formula is R to X. The next important guy, Alkanol. What is the functional group of alkanol class? OH. But this one is a monohydric. This one is what? Monohydric. The general molecular formula, CnH2n plus 1 OH. CnH2n plus 1 OH. Which means that the general structural formula would be R attached to what? OH. Now, if you are asked if alkanols are acidic or alkaline, what do you think will be your answer? Acidic or alkaline? Acidic or alkaline? Acidic or alkaline? Alkaline or acidic? Okay, you are seeing OH, bar. Now, that OH there, please listen. That OH there is not ionizable. Am I communicating with you? When you talk about an alkaline substance, it is a substance that can produce ionizable hydroxyl groups. I guess what I'm saying. So when the hydroxide ion can be ionized, you are talking about your alkaline solutions. Hydrogen is associated with the ability to produce hydrogen. True or yes? Arrhenius definition now. An acid is defined as any compound which, when dissolved in water, produces what? Hydrogen. So base, the other one. Now, but in this case, the hydroxyl group is not ionizable. Is what? Not ionizable. So you don't refer to this thing as alkaline. However, alkanols are more acidic than they are alkaline because they can displace hydrogen. Am I communicating with you? They can produce hydrogen. They can transfer hydrogen. And according to Bronsted-Lowry, any substance that has the ability to give or donate a hydrogen is referred to as what? An acid. So alkanols are more acidic than what? Alkaline. One of the reasons they are acidic is because of the inductive effect that occurs between the oxygen and hydrogen, which makes oxygen to be extremely negative and hydrogen to be extremely positive. Because of that, that hydrogen there can now take a form of an ion and leave the alkanol. Whether you understand, just take note of this majorly. The point about it is this, listen, that the hydrogen in the OH of an alkanol can be replaced. What did I say? Hydrogen in the hydroxyl group of an alkanol can be what? Replaced. Am I communicating? And that is actually one of the tests for an alkanol. If you bring in a metal, normally, when a metal reacts with acid, listen, when a metal above hydrogen reacts with acid, it displaces hydrogen. I take this. Listen, let's switch to inorganic a little bit before I come back. I told you that there is something called the electrochemical series, or, okay, activity series. King Nana can do what? Marry all Zarian female slaves, provided he and the rest of them. Now, any metal above this has the ability to chase hydrogen away from an acid. I keep saying this. Imagine, for instance, Davido is one of your, okay, is your boyfriend. Davido is your what? Your boyfriend. And one guy in this class wants to take away Davido. Is it possible? But imagine, what? Imagine Gene, that the freshest boy in this lesson center is your boyfriend. And then Davido just comes in and is like, yo, baby, can I become your boo? You get what I'm saying? Let me ask you a question. What will happen? Will Davido displace the boy? You'll be like, Davido, I've been single all my life. Oh. You will not even remember you used to have a boyfriend. Now, so you do. Watch out. You are not like what? Is it because Davido have not come back? Uncle, we are not like that. Some of you that is even urgent 2K that used to replace. Anyone that pays urgent 3K. If the one you have now is very urgent 2K, and another one comes with urgent 3K. Sorry, that's what happens actually. Sorry. Both male, female. You understand? Guys, if we see better job, like, why do you think I'm still teaching? I've not seen a job that pays me in millions. That's what I'm saying here. You say it's passion. What? Make a your jam or your company job now. All the passion will end. Let's continue. Now, Mg is higher than hydrogen. Can Mg replace hydrogen? So if that happens, you will now have MgCl2. And hydrogen will now be lonely. He is so lonely. What now happens? Oh. So that's literally what happens. It's a displacement reaction. Now, it is actually one indication of the presence of an acid. That's what makes a compound. If you want to test for an acid, introduce a metal that is above hydrogen. If hydrogen gas is produced, it means that that substance is acidic. Am I communicating with you? Now, if you react an alkanol with sodium metal, react an alkanol with what? Sodium metal. You will notice that hydrogen gas will be what? Given off. So just in case you come across a question and they ask you, a reaction of ethanol with sodium metal gives dash. What gas? Please, what gas is going to be produced? Hydrogen gas. Am I communicating? Good. So just note that alkanols react with very reactive metals. Alkanols react with very reactive metals to produce hydrogen gas. I guess our 2 hours have reached. Is it up to 2 hours? It's not up to 2 hours, right? What's the time? So 10 minutes remaining. Yes, we can achieve a lot. Now listen. Hey, are we tired of the class? Break, ba? Should I give you guys a little break? Sorry. 20 minutes remaining. Okay, so let's push it for the next till it's time, right? Then we take a break. Calm down. At least let's see if we can finish the table. Listen, I must talk about naming today. I must talk about isomerism today. The rest you can read up. But if we can, we'll talk about it. But then listen. I must talk about what today? What must I talk about? Naming and what? Isomerism. Even if I don't talk about the rest, you can find a way around it. Or I could create a study and then send it across to everybody. You get? So as I was saying, let's continue, please. The next homologous series, go back to your table. Important one is alkanal. Alkanal or aldehyde. Not all. Alkanal. Alkawetin. Did I say null? What did I say? Or what? Aldehyde. Now, the functional group of alkanal is referred to as carbonyl. It's referred to as what? Is referred to as what? Carbonyl. Nil. Oh, Jesus. Which one? Nil. Carbonyl is C double bond to oxygen. What did I say is carbonyl? When carbon forms a double bond with oxygen, please, what functional group is that? Carbonyl. Now listen, the carbonyl has two homologous series under it. Alkanal and alkanol. What are the two homologous series under it? Alkanal and alkanol. Now, but the question now is, how do we now differentiate? How do we know which one is alkanal? How do we know which one is what? Alkanol. The two of them have the functional group C double bond to what? Oxygen. How do you differentiate an alkanal from an alkanol? Very simple. We'll look at the structural difference before we look at the difference based on reaction. So listen, before we continue, we'll go to your side note. Oh, your side notes don't full. That's the idea now. Okay, it's no more side, it's not the main note itself. The table is like a side table. Okay. Now, the functional group on our table is terminal carbonyl. Sorry, I forgot to, I made that mistake. Terminal waiting. If you are dealing with your alkanal, the C double bond O exists where? Terminally. Put that down. Oh yeah, side note. The carbonyl group of an alkanal, the carbonyl group of what? An alkanal occurs terminally. The carbonyl group of an alkanal, where does it occur? Terminally. The carbonyl group of an alkanal, where does it occur? Terminally. The carbonyl group of an alkanol, an alkanal, right? Where does it occur? Terminally. So the implication is that if you see C double bond O, you suspect two things: alkanal, alkanol. But how are you going to know the one that is alkanal if the C double bond O occurs where? Terminally. Are you now right? Before I illustrate, you write. On the other hand, the carbonyl group of the alkanones, the carbonyl group of the what? Alkanones. The carbonyl group of the alkanones exists non-terminally. How does it, or where does it exist? Non-terminal. It occurs non-terminally. What do I mean by that? Listen. Very simple. Listen. You have this. C. What's happen? Any problem? What's the problem? Okay, I tell people. Yes, what's the problem? Talk. I said the carbonyl group of alkanals occurs terminally, while the carbonyl group of alkanones occurs what? Non-terminally. What is terminal? Shade the end. Which one of these is an alkanal? The first one or the second one? Why? C double bond O. Where is it existing? This one now, what is it? What is this one? Okay, let me just give you a little tip about naming your compounds. I said prefix, infix, suffix. Prefix, infix, suffix. Your infix tells you the number of carbon atoms in the parent chain. So if you have 3 carbon atoms here, this is prop. Then you have carbonyl, non-terminal. What homologous series? Non-terminal carbonyl. Alkanone, So this will be proper. No. Am I communicating? Now, but because the carbonyl is on the second, it will now be 2 propanone. I'll still explain when I get to naming. But I'm just giving you a tip of the iceberg in naming. Am I communicating? You now have this. What is this one going to be? 1, 2, 3. Proper waiting. Why? It's an alkanal. Terminal carbonyl, alkanal. Non-terminal, alkanone. I hope this is understood. Okay. Moving ahead. When you now talk about the reactional or chemical differences. First of all, is if you want to identify a carbonyl group, a carbonyl group is indicated, the presence of a carbonyl group is indicated by what we call Brady's reagent. Brady's reagent is 2,4-dinitrophenylhydrazine. I will write it. Charun, what's your problem? As I was saying, listen, guys. Listen, I was saying something. Listen. I said that if you want to check for the presence of, please listen, the presence of C double bond O in a compound, that is whether you want to test for alkanals or you want to test for alkanones, you can use what we call Brady's reagent. What did I call it? BRADY, S reagent. So you can write Brady's reagent is used to test for Brady's. It's not Gladys. Brady's what? Reagent. Brady's reagent. I should spell what? Alkanone. Brady's reagent is used to test. Listen. Brady's reagent is used to test for what? Your alkanal and alkanone. That is the presence of a carbonyl group. So Brady's reagent is used to test for the presence of a carbonyl group. Brady's reagent is used to test for the presence of a carbonyl functional group. Are we there? So if I want to test for alkanal or alkanone, Brady's reagent. Are we listening? What is Brady's reagent? 2,4-dinitrophenylhydrazine. 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 It forms yellow precipitate when combined with the carbonyl group compounds. It forms what? Yellow precipitate when combined with the carbonyl group compounds. It forms what? Yellow. What color? Yellow precipitate when combined with what? The carbonyl group compounds. Okay. A brief question. How do you form alkanones? Who can tell me? Alkanones. Yes? How do you produce them? Oxidation of? Good. How do you form alkanals? Partial. When you say partial, listen. When you are doing partial oxidation of your alkanol, it means that your alkanol will be in excess. Alkanol will be in what? Excess. If it is complete, your oxidizing agent will be in excess. Sorry, I hope I'm communicating. Good. So you write that down. What did I even say? It gives yellow precipitate. Am I communicating? That's Brady's reagent. The structural formula. Phenyl. Phenyl is benzene when it is attached as a substituent. Am I communicating? When benzene occurs as a substituent, it is referred to as what? Phenyl. That's why when we had benzene substituted to OH, this is phenyl alcohol. What do we now call this? What did you now call it now? Phenol. How about phenyl alcohol? Because as a substituent, benzene is referred to as what? Phenyl. Am I communicating? When you want to name benzene group as a substituent, what do you call it? Phenyl. OH, how about alcohol? When you combine a phenyl with alcohol, what do you get? Phenyl alcohol, which is phenol. Are you seeing how these names are actually formed? Good. So have that in mind, just in case. Now, with that said, phenol. Give me a major use of phenol. Phenol. Disinfectants. What did I say? Another use of phenol. Disinfectants. As I dey talk am, just the right term. Now, exam we dey prepare for. We don't know where they won't come from, but we really know. Because by the time we are done with this study, you are going to be prepared. Hopefully. I don't know if we can finish everything. Okay. So as I was saying, phenol is used as what? A disinfectant, or used in the making of disinfectants. Now, another major use is that Ishi plug. Do you know what Ishi plug is? You know your plug now, your generator plug. That white part. Do you know that white part? That white part is made from a thermoset plastic. It's made from what? You know, we are supposed to do polymerization, but then just know it now. That it is made from what? A thermoset plastic. Thermoset, there are two forms of plastics. Thermoplast and thermoset. Thermoplast implies that you can remold it, reheat it, remelt it. Thermoset, once it have formed, it have what? That's why it's called thermoset. If it's set, it don't. Understood? So bakelite now is an example of a thermoset formed by copolymerization. Bakelite. B-K-E light E. Now listen, bakelite. Now the bakelite, listen, is what is used to coat the Ishi plug. That white part you're seeing in your Ishi of plug, the head of the plug now. That white part now is referred to, the plastic there is what? Bakelite. And listen, the bakelite is made up of two monomers. Number one is phenol. What is number one? Number two is methanol. Bakelite is made up of two monomers. Phenol and what? Methanol. Another name for methanol is formaldehyde. Another name for methanol is what? Formaldehyde. Bakelite. What are the monomers of bakelite? Phenol and waiting. And what? Methanol or formaldehyde. So you notice that a second use of phenol now. It is used in the polymerization, copolymerization to form the bakelite. Bakelite is Ishi plug. What did I say is bakelite? I don't know what I'm saying, but you get my points, bah? That white part for plug head. You don't know what plug is. Don't you know what generator is? You don't have gen. What do people have? Lister. Oh, you use solar. Human beings that have sense here, you know what I'm saying, bah? The rest, did I say they are not human beings? Let's continue. So that white part, that thing where they did like, I know sabi draw. Now my problem, if I draw now, you're not going to know what it be. Then you come and have something like this. Whoa, nah. Just forget about it. My point is, you get something where they did gen white. You get white head. Sure, you know that white head. Now bakelite. Now waiting. What are the two monomers of that bakelite now? What type of plastic is bakelite? So if you're another thermoset plastic, una no go make a PVC. Have you heard of PVC? PVC is polyvinyl chloride. It is a thermoset plastic. Am I communicating? Anyway, we'll hopefully touch that. But I just wanted to mention that since I talked about it. So please listen. What is the reagent used to identify your carbonyl group compounds? Brady's reagent. What's the IUPAC name? Phenylhydrazine. Okay, if you're looking at hydrazine, NH2, phenyl, 2,4-dinitro, NO2. So this is the structural formula of phenyl 2,4-dinitrophenylhydrazine. When you talk about hydrazine, NH2 is hydrazine. Okay, you are wondering how I put 2,4, ba? Watch. The major functional group here is this hydrazine side. So it will carry number 1. This is number 2. This is number 3, number 4, number 5. So this is 2 and what? Number 3, number 4, number 5, number 6. So this is 2 what? 4. Dinitro, meaning nitro will be how many? 2. That's why we have this. Your paracetamol Para-acetyl aminophenol. Yes, now. Paracetamol now. Para-waiting. Aminophenol. What does it mean? Phenol. OH is the major bar. Are you hearing para-acetyl aminophenol? What is phenol? Phenol. Okonya. So, but they said para-acetyl. When you say para, it means it is at a para. Thank you. What is parallel to OH here? Here. Are you getting the point? So you will attach your acetyl amino at this point. CH3. Are you listening? C double bond O NH2. So this is the structural formula of paracetamol. Para-acetyl. I talked about the acetyl group attached to amine. Para what? Acetyl. Para 1,4 parallel. Acetyl CH3C double bond O. Amine. Am I communicating? Amino waiting. Phenol. Okay, I'm not communicating. Forget about it. This one will not come out. Don't worry. I'm just trying to show you something. So listen. You want to write it down too? Oh yeah, why are you saying you don't understand? Write it if you want to. Okay, you don't understand, but just write it. It's okay. Aminophenol. Para-acetyl aminophenol. Para-acetyl aminophenol. Okay, let's continue. No worries. Let's just continue. Oh, it's time. 2 hours don't reach. It don't pass. Okay, now please listen. Listen. If I say this, we'll stop by 5. No, not dismiss by 5. Should I dismiss you guys? I will faint here. I've not eaten. Don't even have mercy. Oh God. When are we going to dismiss? Night class, Ishigi. Your parents don't trust you. See school, Hannah, they will start calling us. And now listen, please. Let's just. I just want to give this so that when we come back, the rest are not so hard. Listen. You know what is taking our time now is that I am asking questions. I am touching some intricate parts. Are you listening to me? If you take this study and enter the exam hall, when we are done with naming and isomerism, I am almost 100% sure that out of the 7, out of how many? 7, you will know 4 or 5 without reading extra. Listen, did I say you will know 7? You will not know 7 now. If you want to know 7, you have to read everything. I am just preparing you for the exam. You will know at least 4 to 5. In fact, what am I saying? I just talked about identification one time earlier on. I've forgotten the particular set, I thought. And most of what came out was identify the functional group, which homologous series, blah, blah, blah. And that was all that came out. So imagine that what comes out is just this one. You see, if JAM, imagine JAM gives you people like specific area of concentration. They say this year, all we are going to ask is Alkane. Hey! If we don't get 100, hey, God. I beg. Say this and then we'll stop. Now, but I'm saying it. Common sense. Let's apply our common sense. What? You don't want to apply common sense again? Now, apply your common sense. I said, I've talked about the structural difference between alkanol and alkanone, right? I've talked about it, right? Good. Now, the next difference I want to talk about, listen, please. The next difference I want to talk about is the reactional or chemical difference. The what? The chemical difference. Again, a chemical difference. Now, earlier on in the class, we talked about the primary and secondary alkanol. And we said that a primary alkanol will give alkanal. No be so. On oxidation, if you further oxidize alkanal, reduction of alkanoic acid produces what? I hope you know that. Okay, somebody said alkanal, right? Now remember I told you, if they don't indicate incomplete, it means complete. So if I just say reduction of alkanoic acid, what will it give? Primary alkanol. You only choose alkanol if that is the only option. Like you check, it's just alkanol that is there. Am I communicating? But specifically, what should it give? Primary. Oh yeah, watch this. Secondary alkanol. When you oxidize it, what will it give? Alka what? If you further oxidize it, what will it give? Nothing. Now, that means that, listen, to differentiate alkanal from alkanone, oxidation reaction. Alkanals can be further oxidized, but alkanones cannot be oxidized. So, when you introduce your Fehling's reagent, which is a major constituent is copper 2 salt, am I communicating? As an oxidizing agent, will it oxidize alkanal? Will it oxidize alkanal? So would there be a reaction? Yes. When that reaction occurs, the Fehling's reagent will oxidize alkanal to form alkanoic acid, while itself will be reduced from copper 2 to copper 1. Color of copper 2 is blue. Color of copper 1 in a solution is what? Brick red. Copper 1 in a solution is what? Brick red. So when you introduce Fehling's reagent to an alkanal, it will oxidize the alkanal and become reduced to what? Brick red colored copper 1. I take it again. Alkanal can be further oxidized. Alkanone cannot be further oxidized. So if I want to differentiate them by their chemical reaction, all I need to do is to introduce an oxidizing agent. What are the popular oxidizing agents used? Fehling's reagent and Tolling's reagent. Fehling's reagent and what? Tolling's reagent. Fehling's what? Reagent and what? Tolling's reagent. Fehling's reagent is, its major constituent is copper 2 sulfate salt. The major constituent of Fehling's reagent is what? Copper 2 sulfate salt. Now, we already know that oxidizing agents are reduced in organic chemistry. True or yes? Not be so. Reducing agents are oxidized. Oxidizing agents are what? Reduced. I tell you now. Okay. I think most likely I've taught you guys about that earlier on. We discussed and said, if for instance I am an agent of darkness, for what? Instance. For what? Who says we know? It's not by shining black. If we are looking for agent of darkness here by color, I will not be the agent of darkness, I'm sure. It's me. You see this guy? Even you, when they talk, is you, Sam. Okay, so let's continue. Now, listen. If I am an agent of darkness, what will I cause to happen to you? Shall darkness will happen to you. But what will affect me? Light. So, agents of darkness are affected by light. Same way, oxidizing agents are affected by the opposite reaction, which is what? Reduction. Reducing agents are affected by the opposite reaction, which is what? Oxidation. Okay, let's leave that. We're not in an organic chemistry class. Listen. So my point is that if you introduce an oxidizing agent to alkanal, can it further oxidize it? Yes. But if you introduce it in alkanol, would there be any reaction? No. So put Fehling's reagent here. Brick red coloration. Fehling's reagent plus alkanal. What did I say? Brick red coloration. Fehling's reagent plus alkanol, no reaction. Fehling's reagent plus alkanal. Fehling's reagent plus alkanal. What did I say? Brick red coloration. Now, why do you have brick red? Because alkanal can be further oxidized. Fehling's reagent plus alkanal. What do you have? Brick red coloration. Fehling's reagent plus alkanone. What do you have? No reaction. No what? Reaction. Then finally, before we go on a break. Now, listen. If you talk about your Tolling's reagent. Listen. If you talk about your Tolling's reagent, its major constituent is silver trioxynitrate 5. What did I say? What did I say is the major constituent? So whenever you introduce, listen, stop writing. Oh God. Mona, calm down. I said empty head, complete note. If they pass exam, so fill your head first. I will give you the notes. Toluene's reagent, its major constituent is silver trioxonitrate 5. If you introduce it to alkanal, would there be a reaction? Yes, because there will be further oxidation. Am I communicating? Now, the silver, which is silver plus 1, will be reduced to silver neutral. And that silver neutral will now start pasting on the inner walls of the test tube. So, when you pour in Toluene's reagent to alkanal, what you will have as your result is silver mirror of the inner walls of the test tube as a result of reduction of silver plus 1 to silver metal. Am I communicating? I'm not communicating. See what I'm saying? Alkanal will further react, bah? Good. If you pour Toluene's reagent, it will react with it and then form silver solid. That's all I'm saying. Those solid will now be deposited on the inner walls. Am I communicating? And that's why you have what we call a silver mirror of the inner walls of the test tube. I take it again. Toluene's reagent, alkanal, what will you see? I told you why you have brick red now. Is reduced from copper 2 to copper 1. That's that guy. Toluene's reagent, what are you going to have? Silver mirror. Silver what? In the inner walls of what? The test tube. That's that. Manitinia and alkanol, would there be any reaction? No. Am I communicating? So that's that basically. So you have that. Toluene's reagent, right? Plus alkanal results in silver mirror. Hi. Silver Milo. No, it's Milo. Toluene's reagent plus alkanal. What will it result in? Silver mirror formed in the inner walls of the test tube. Silver mirror formed in the inner walls of the test tube. Toluene's reagent plus alkanol. What do you have? No reaction. Why? Alkanones cannot be further oxidized. So, if for instance you are asked, which one of these reactions, all these reactions occur in an alkanone except option A, substitution, option B, oxidation, option D, reduction. What's your answer? Oxidation. Alkanones can never be oxidized. Am I communicating with you? Alkanones cannot be what? Oxidized. Okay, at this point, at this junction, let's just write down this guy. We said functional group of alkanal is terminal carbonyl. Then alkanone is what? Non-weighting. Terminal weighting carbonyl. Just know the spelling. I know the right to impress you people again. Online. Manage. I'm tired. I need to. Okay. General molecular formula for alkanal. CN H2NO, where N equals 1, 2, 3, ... What is the general molecular formula of an alkanal? See, when I know they see this board, hunger don't enter on the eye like that. Wait, make I write and where? Wait. No worry. Wait first. Course rep, you pack 20 marker. When no the right way. Wait, for those that are hungry. Where is the one? Village people, they walk, oh. CNH2NO. Now listen. Now the fact that it is the molecular formula is this doesn't mean it is arranged like this. When you are sorry, where did I say N starts from? 1, 2, and so on. Are you guys what I'm saying? Good. But then when you look at how it is structurally arranged, you structurally arrange it as R alkyl group attached to the carbonyl, then hydrogen. Another way of writing it is RCHO. Structural formula of alkanal, R attached to carbonyl and hydrogen, or RCHO. That is how you write it. when you are representing it structurally. But the general molecular formula is CnH2nO. Now, alkanone, non-terminal carbonyl, their own general molecular formula is CnH2nO. Please, what does this imply? That they are what? Isomers. They have the same molecular formula, but they are different compounds. So automatically, they are referred to as what? Isomers. So if you see a question and they said, which one of these is a corresponding isomer of alkanol? Alkanone. Alkanone. What is your answer? What if it is propanone? Am I communicating with you? Hope this is understood. Now let's move on. Now, in the structure, N here starts from 3. Yes. N in this case starts from 3. Now, why does N start from 3? It has to be non-terminal. If there are only 2 carbons, can you have a non-terminal? For you to have a non-terminal, there must be at least how many carbons? 3. That's why N for propanone starts from what? 3. Am I communicating? Good. So N starts from what now? 3. Then finally, before we go on our brief break, R, C, double bond O, waiting, R. Okay. Oh. How many minutes are we taking as break? 15. What's the time now? 5:04. Let's come back by 5:20. 5:20. It's too late. 5 waiting. 5 waiting. Those online, when should we come back? Those online, when should we come back? Why didn't you at home? You are saying they're at home. What did they say? Those online? 5:10. Ha! I'm a human being, no. 6:30. See, if it's 6 o'clock and you need to go, you can leave. Or your break. 10 minutes, 10 minutes, 10 minutes. Thank you.